Okay, so what we're going to do then, we're going to get started and go through these recap questions. So I know a couple of people have already put these in, absolutely fine. If you're still working through them, don't worry, we can talk through them together. So question one, and this seems to have thrown a couple of people, we should be looking for 30 here. This is a percentage question that would only pop up on a calculator paper. It wouldn't pop up anywhere else. Yeah, that's looking good, Nicola. So question one, spot on. Yeah, not too sure about the next ones. I like that you've given the decimal answer for number 3, so I'll have to double check that one for you. And number 5 there should be a negative. But again, we can see that in just a second. But spot on for number 1, which is always good. So this one here, then, so we should have 30. The reason or the way that we found that is that we have 125 divided by 100 and then multiplied by 24. It's really the only kind of quick way to find this because it's not in a multiple of 5 or a multiple of 10. For question 2, we should be looking at an answer of 54 here. If we take 90 and we divide that by 5, then you should end up with 18. So 18 is 1/5. And then when you multiply that by 3, you end up with 54 there. Okay, so our fraction problem here then, so our adding of fractions. I'm going to show you two different ways of looking at this one. So first of all, if we look at this, we can see straight away, well, I can't add these fractions. The reason being the denominators are different. So we must find a common denominator. It comes back to that link I was saying yesterday. If you try and say it in English, you can't. You know, if I ate 4/6 of a pizza and 1/5 of a pizza, I can't say I ate 5/6. Do you know what I mean? I can say I've eaten 5 of something, but I don't know the sizes. You've got to find a common denominator. Easiest way to do that is, well, if I multiply 6 and 5 together, that will tell me a number that is in the 6 times table and the 5 times table. Might not be the simplest, but it will always be a number in both tables. So 6 times 5 will give me 30. How I've got there is I've multiplied the left fraction by 5 and the right fraction by 6. When I add the tops there, I'll end up with 26/3. I can then simplify this fraction to 13/15. This is one way of doing it. Another way of doing this is actually some people might have simplified this fraction at the beginning. So you might have gone, well, 2/6, I could write that as 2/3. And then do the same thing. I'm still looking for a common factor, but the common factor that you'll find is this fraction straight away. So hopefully that helps you spot as well that it doesn't matter if you simplify at the beginning or if you simplify at the end, you will end up with the same answer inevitably. So again, adding fractions, it's all based on our equivalent fractions and our ability to find equivalent fractions and be comfortable with them. So question 4 then, and again, this will make more sense after today's topic, after we've looked at conversion. But this is the idea of, you know, what is 12 as a percentage of 80? Now, this was something that was a little bit confusing when we looked at this in percentages. But when we've now looked at this in fractions as well, it makes a bit more sense. I can just write that as a fraction. Well, it's 12 out of 80. We all know now that a fraction is just an incomplete sum. When I complete that sum, I end up with 0.15. To switch this into a decimal, I'm going to then times it by 100. This will make sense a little bit later on when we practice this switching from decimals to percentages. But essentially, this shows how all of these are linked. They are all the same thing. Okay, so for that one then, we should have 15%. Our next one then, and this one's got a couple of people as well. This is an example of a BIDMAS style question that you might get. They don't tend to go into negative numbers very often, but just to make you aware. So when we're looking at this question, what we have to ask ourselves first of all is, well, what am I doing first here? There's no brackets, there are no indices, there is no division, so it is the multiplication that comes first. You can view it either way. You can just look at this and go, well, 2 times 6 is 12. And then obviously just put the rest of the sum back in. Or you can imagine it, and again, the sign in front of a number is always linked to it. So you could look at it as this is -2, and I've got 6 lots of -2, which is -6. Sorry, -12. Either way you view that, you still end up with the sum 5 minus 12 or 5 take away 12. When we complete that sum of 5 take away 12, you will end up with a negative 7. So I know a lot of people put a positive 7 there. Just remember, you are actually going into the negative. We can't take 12 away from 5 without becoming negative there. Okay, and then finally then what we have is our compound interest question. Again, this is only over 3 years. So if you think about it, if we want to solve this using simple interest, which I do recommend, I really do, for the majority of people, if that formula, if you don't understand how the formula works, or if you're worried that you're not going to be able to remember it, it probably isn't even worth putting to memory. If you think about it, if you get into the exam, but you're not going to feel confident to use that, then what's the point? Because you're going to revert back to this method anyway. It's just a bit of wasted time there. It is a very nice method, though. It does help speed things up. It can lessen stress or anxiety in some cases, but it's entirely up to you. If I wanted to work this out, let's say the longer way, I know I've got £800, which is 100%. I'm going to find my 1% as I always do. So I'm going to divide that by 100, and there is my 1%. I'm going to triple that or multiply it by 3, which will give me 24. So I now know what 3% is. And obviously in Sally's account here, this amount is being compounded for 3 years. So in year 1, it will be £824. That's it. That's the end of year 1. Then when we start with year 2, we then look at the new amount and we find 3% interest of that. So just remembering the difference, simple interest will be the interest amount at the beginning will just be added on. So over these 3 years, Sally will just gain £24, £24, £24. With compound interest, it'll be £24 the first year. Next year, it'll be 3% of 824. The following year, it'll be 3% of whatever that may be as well. So all you have to do with this question, although it can look a little bit difficult, you are just repeating those steps over and over and over again. The 26 over... sorry, Nicola, I'm not too sure what you mean by that.
Sorry, do you know what? I was just going back to question 3, but I was typing to say when you finish doing this current question.
Got you.
Sorry.
No problem. I was looking at it, I was like, I don't know where that's come from. I was like, okay, I get you now. So
I got the 30, but I just thinking, how did you get the, I can't remember how you got the 26. That's all it was. So,
all right.
but please finish that question.
Okay, no problem then. I'll just quickly round this one off then, and then we'll have a look there. So if you have tried this question, then again, if you're using the formula, it will work considerably quicker. And you should end up with an answer of 874.18. Again, they will accept a small range of answers here. So, anywhere between, 874 and 874.3 maybe, they will accept those answers. Again, when I'm using this formula, and this will make more sense after today's session, all I'm actually doing, this whole bit inside the bracket that I'm doing first, all I'm doing is essentially writing, well, I've got the whole thing, 100% and 3%. 3% as a decimal is 3 over 100. I'm just writing it as a decimal so that my calculator can do that sum. The indice or the power up here just tells me how, obviously that's going to make it repeat that many times. Like when we square a number, we times it by itself twice. When we cube a number, we do it 3 times. If we were to quadruple a number, we'd do it 4 times. This will just repeat the interest that many times on this amount of money. So it's a self-sustaining system. Absolutely brilliant. Okay, so Nicola was asking there so about this question here. So if I quickly recap, so what we've done, we found the common denominator of 30, and people are quite happy with that because we've looked and we've gone, well, I've got a 6 here and a 5 here. So something, a multiple that they will have in common is 30. The reason I'm multiplying them is essentially they don't fit into each other, and I can't simplify one to go into the other. So I'm essentially just writing out my 6 times table until I find a number that fits both. That's why it is a common denominator. So I'm writing out this. I'm also writing out my 5 times table, 15, 20, and so on. And it's only 30, which will be the first kind of number that they both have in common. The shortcut that I've used here is that I have just multiplied each side. If I multiply 6 and 5, the outcome will be in the 6 times table and the 5 times table. And it tells me that 30 will be that outcome. All I then have to do is work out what have I done to each side. Here, I've got a 6 and I've multiplied it by 5, which means the whole fraction is getting multiplied by 5. So 4 times 5 will be 20. So here I'll end up with 20 over 30. The next fraction here, I've multiplied all of this by 6, so I end up with 6 over 30. When I put them together, I get my 26 over 30 there. So I'm hoping that that explanation kind of breaks it down a little bit more for you and makes sense. Cool, which I've got confirmation that it does, so brilliant stuff. Okay, so a bit of a recap on some of the skills we've been looking at then. We're going to look at our first topic from today, which is conversion, and hopefully this is one of those sessions that should bring everything to a nice close for us in regards to fractions, percentages, and decimals. So for the first part then, what we're going to look at is an introduction to conversion. What is it? Why we use it? We're going to look at how to convert between all of these different numbers. So we've got between fractions and decimals, decimals and percentages, etc. We're going to look how we switch between all of these. A lot of the skills we have already covered, so do not worry. We're then going to have a little bit of a look at what these look like in exam form as well. So there are some exam style questions at the end of this assessment, which we will look at as well. But we're going to look at the two main types of problems that we come across. One of these, I'll explain now, like one of them is a very straightforward switch this fraction to a percentage or switch this decimal to a fraction. It's just, they will just ask you to switch something. Tends to be on the non-calculator paper, can be level 1 or level 2. For the actual, the other type of question that we tend to find is that you're given three numbers. One might be a percentage, one might be a fraction, the other might be a fraction. And we're asked to compare them and see which is larger. In that case, that's where you get a lot of kind of variable. You can manipulate them how you want. You can switch them all to decimals, all to percentages, but you're going to convert them all to something common so that you can then view them and compare which is larger, which is smaller. Okay, so the main question then is how many pairs of shoes do you have? So the reason for this, what seems very, very pointless and weird question, is why? You know, why do you have so many pairs of shoes? Yeah, most people have 2 or 3 pairs. Yeah, you might have considerably more than that. I know some people do. But why? They all do the same thing. They all go around your foot. They keep your foot warm. They keep your foot dry. And, you know, they stop your foot getting injured, I guess. They all go on your feet, basically. So if they all just go on your feet, why do you need so many pairs? The idea here is that different shoes, although they all do the same thing, are better in certain situations or certain environments. If I'm going down the beach, I'm going to wear some awesome flip-flops with no socks, and I'm going, you know, that's going to be the most comfortable thing I can wear. I'm not going to go down there in high heels because I'm going to snap my ankle. Similarly, so if I'm climbing a mountain, I'm going to wear big, thick mountain climbing boots that are going to support my ankles nicely. They're going to have a lot of tread on them, so I've got more grip. Yeah, they're going to help. I'm not going to wear kind of businessman shoes like this. The idea that I'm getting at is that although they're all the same, they all have functions that can be more beneficial in certain areas. It's the exact same with fractions, decimals, and percentages. All of them show us a part of the whole. They all are written in a slightly different way. Sometimes it is easier to use one form than another, and sometimes it is more preferable. So some people might prefer to put everything as a percentage. Some people might prefer to write everything as a fraction. It's entirely up to you. But what we're going to look at today is how we switch between them. It's a bit strange, obviously, they all exist because, well, we had fractions first, then we kind of invented percentages, and now we finally invented decimals. So that's why we have 3 different sets for this. But again, sometimes it's kind of ingrained into a lot of things. If you think about cooking, like I said before, if I've got 2.5 tablespoons of syrup going into my recipe, that sounds fine. if I were to read that and say, oh, I need 250% spoons of syrup, you'd think I was a bit weird. So there's, sometimes it's better to use a fraction, sometimes a percentage, and so on. So what we need to be able to do is effectively switch between all of these different things. We're going to go through a couple of these and kind of look at the different methods. And again, like I mentioned, some of them we've already looked at, which is absolutely brilliant. I'm hoping this is a very kind of penny dropping kind of lesson for us. So first of all, we're going to look, well, if I've got a fraction, how do I get to a decimal? And they might ask us, they might just say, look at this fraction, convert it to a decimal. All we have to do is remember that a fraction is just a sum. So we just complete the sum. That's it. We've already looked at this. We already know how to do this skill. For instance, if I had 1/4, that is the exact same. That line in the middle just means divided by. It is an incomplete sum. 1/4 is 1/4. So 1 divided by 4, if I go through my bus stop method, I will end up with 0.25 there. Now, the great thing with these is, again, it will work with any fraction that you want. So again, as a common example, most people are aware of half being 0.5. The reason being it's 1 divided by 2. So therefore, okay, well, oh, sorry. So how many 2's are going to go into 1? That will be 0. Our 1 carries into our decimals, and then I've got how many 2's into 10? 5. All I need to do to get from a fraction to a decimal is complete the sum. And the great thing is, we can do this. If this pops up on a non-calculator, we know how to do this using long division. If it's on a calculator paper, though, this will do it for you. The most important button, or one of the most important buttons on here, is there is an SD button, which you should be able to see there. So this SD button, when you type in a sum, it will switch from standard to decimal. So at this point here, I've typed in there 1 divided by 4, I've got 1/4. If I press the SD button, it will change it to a decimal for me. The even better thing about these calculators is if you have a bigger fraction, it will simplify it for you. So let's say if I had an equivalent fraction here, let's say I had 10/40, the calculator will simplify it to 1/4, and it will tell you the decimal as well. So it really can help us save a lot of time there. Essentially though, if we want to find a fraction of an amount, we just complete the sum. That's all we have to do. Okay, so there are some questions or practice questions here for us to try out this new skill then. So again, maybe do use the calculator for 1 or 2 of them if you want to, kind of like practice getting used to how the calculator works. If not, try your long division method. Some of these will go to numbers that are longer than 2 decimal places, just so that you know, they might go 3 or 4 decimal places, absolutely fine. But do have a little bit of a look, see how you do them, and pop me over the answers when you got them, and I can go through and explain how we're doing. Katie, yeah, that's absolutely perfect. So that's for number 3. I'm assuming the first 2 you obviously already you already know them, but yeah, for number 3, that's absolutely fine. You can look at it as well if you think, well, if that's 1/5, if you were to multiply that decimal by 5, what answer would you get? It's always a case of remembering that all fractions are out of 1, all decimals are also out of 1. So if you multiply that answer by 5 and you end up at 1, then you've definitely got the right answer there. But just to help a little bit, I'm just going to go through, obviously, our first two we've already looked at. So we've already got answers for these from the previous kind of slide there. So we know we've got 0.5 and 0.25. Just to help people out a little bit. So for number 3, you should end up with 0.2. I know it's quite difficult to kind of feel confident in stuff sometimes. So if we look at this, so 1 divided by 5, I'm going to view it as, well, how many 5s go into 1? That will be 0. The 1 carries over into our decimals. I've then got how many 5s go into 10, which will be 2. So this is why 1/5 is 0.2. It's the same as, it is the exact same thing. It's just written in a different format. Peace, yeah, that's absolutely brilliant. So that's spot on for question 1 in the achieving bit there, and question 2 there as well. That's perfect. Well done there. Again, don't worry about the titles there. That's just from where I was teaching in a school before a couple of years ago. That was the grading system that I wanted to use for some reason. Doesn't mean anything to us. They just progressively get a bit more difficult as you go along. Katie, yes, absolutely awesome. That's spot on for a conversion of 1/8 there. So just give you guys another minute or so, and then I'll start going through the next ones for us. Okay, so let's have a look at these next ones then. So we've got 1/8, which when we complete that sum, it does go on for a little bit, and sometimes these fractions can. They're not always going to be the nice ones. This will end up as 0.125. This is a prime example. They might use a question like this, and they tend to kind of tag on this extra bit where it might say, convert 1/8 to a decimal, give your answer to 2 decimal places. So that's where you might end up kind of, for converting the fraction to the decimal, you'll get 1 mark, and then it's this extra, give your answer to this many decimal places. They will add it to the end of a lot of questions. It is just one of those skills that they test quite frequently throughout the paper. It's an easy extra 1 mark for us. So we've got 0.125 there. For 3/4, we should have 0.75, and for 4/5, we should have 0.8. A little bit of a pattern that might help here. I know that a half is 0.5. A quarter is essentially half of a half. That is 0.25. I've halved the size of it. I've divided it by 2 again. An eighth is half of a half of a half. So, it's been divided by 2 here, then I've divided it by 2 again. 0.5, 0.25, 0.125. A little bit of a pattern there. The other thing that you might notice here, well, with 3/4, I know what 1/4 is, it's 0.25. So if I've got 3 lots of them, I end up at 0.75. Same here, if I know that 1/5 is 0.2, then 4 of them will be 0.8. So what you can do sometimes, if you want to maybe make the sums a little bit easier, just work out, 1/5 or 1/7, 1/10, whatever it might be, then multiply by whatever you need. Just different ways of looking at the same problem. Okay, moving a bit further then. So these final ones here, so we've got these kind of say 3/8 would be 0.375. Now 1/7 and 3/7, both of these I've had to simplify. And the reason being is when you work out 1/7, you actually get something that is a recurring decimal. So when you actually work these out, the value that you'll get, if you type it in on a scientific calculator, you will get 0.142857. Now, what you'll notice, if this is on a normal calculator, you'll just see that repeat a little bit. It might just go 0.142857, 1428, something like that. Now, on one of these calculators, what you need to be aware of, you need to really pay attention and look closely above the numbers. What you will notice is that in this number, there is a dot above the 1 and a dot above the 7. What that means is that that sequence of numbers will repeat over and over and over again. So if you were asked to find, let's say, a 7th, they would always say, give your answer to this degree. It might be 1 decimal place, 2 decimal places, 3, whatever they ask you to, because that number will go on forever. The last and kind of final question here then, and this is one that I do want to kind of have a little bit of a look at, is, convert a third to a decimal. We know how we do that. We're going to end up with, 0.33333. We've looked at this before. I want to look at 2/3 though, because this has actually popped up as a question, and it's quite an interesting one. So if I have 2/3, so 2/3. So I want to know how many 3s go into 2. It's not going to fit in. What I'm then going to get is my 2 remainder. And I'm going to get, well, how many 3s go into 20? You should end up with 6 there and 2 remaining. And you can see the pattern will repeat. When we have 1/3, it's 0.333333 recurring. When it's 2/3, it's 0.6 recurring. Now, if they were asking you to write this as a decimal, they might say, give your answer to maybe 2 decimal places. So it's important to remember that those 6s go on forever. So when we're looking at 2 decimal places, we're going to draw a line in here, and we're going to obviously round correctly. So we're going to say, okay, if I'm rounding this 2 decimal places, this is my second decimal place. It's either going to be 0.66 or 0.67. Because this is higher, it will round to 0.67. And just to make you aware of that extra little bit there. Okay, brilliant. 1 down, no problems. So fractions to decimals, it's the exact same as what we've done before. It is just long division going into decimals. That's it. Now, the nice thing here is that decimals to percentages and percentages to decimals are incredibly easy, and it is all about the skill that we've already learned before. Essentially, like we were looking at then, a fraction is out of 1. It's always, we've got one thing and we're breaking it into pieces. The decimal answer is also out of 1. Like I explained, with a fifth, it is 1/5 of a total. When we look at it, it's 0.2. If that's 1/5, if I have 5 of them, I've got 1. I've got the whole thing. The only difference with decimal and percentage is that percent, like we looked at, literally translates to out of 100. Instead of looking at it as being out of 1, we're comparing it as if there were 100 pieces. So all we have to do here is multiply or divide by 100. We've learnt this skill previously when we were looking at our percentage lesson itself, but again, it comes up in metric conversion. It will come up in normal conversion here. It's a very, very useful skill. So to switch from a decimal to a percentage, it's just a case of multiplying or dividing by 100. If I am going from a decimal, so in this case, I've got 0.75. If I want to switch to a percentage, I just make it 100 times bigger. Percent is out of 100, decimal's out of 1. So I'm going to make it 100 times bigger, so it's then out of 100. Now, again, all we're doing, if you're someone that kind of looks at it as the decimal point jumping, here's your explanation. If you're more like me and you imagine, okay, well, I've got 0.75, everything gets 10 times bigger and then another 10 times bigger, and you imagine the numbers sliding, this is how you're going to end up with 75. It's the exact same for any decimal. If I have 0.6 and I multiply it by 100, I'm going to end up with 60%. If I have 0.072, I'm going to end up with 72%. You don't always end up with whole number percentages. If this was 3 decimals long, then I'm going to end up with 72 point something. But just make you aware, this is all I'm doing. I'm just multiplying by 100, and we know how to do that. And hopefully it makes sense why we're doing it. Similarly, then, if I'm going backwards, I'm just dividing by 100. If I've got a percentage, well, that's out of 100. So I need to make it 100 times smaller to get to the decimal. So in this case, if I've got 75%, that will become 0.75. And again, with any percentage, let's say I've got 82%. Well, if it's 82%, I need to make it 100 times smaller. I will have 0.82 as my decimal. This is how these are linked. They are the exact same. They are equal to each other. It is just a case of being happy with this fact. Percent is out of 100, decimal is out of 1. Okay, let's have a little bit of a practice of some of these then. So on the left there, you've got 5 questions, and all of these are percentages, and I want you to switch them into decimals. So if you think, if it is a percentage already, it's going to have to get 100 times smaller. Feel free, use a calculator if you want to. Although it is a good point to practice that mental arithmetic skill of multiplying and dividing by tens and hundreds. The other questions on the right there, so questions 6 through to 10, these are all decimals, and I want you to try and switch them into percentages. For most of these, question 1, 2, and 3, and questions 6, 7, and 8, people have no problem. But the reason I've put the extra questions in there is to just get you thinking a little bit. Question 4 in particular is one that pops up very frequently. And it's there just to try and catch people out a little bit. Question 5 and question 10 are a bit more extreme examples of that, but if you're following the pattern, you'll be absolutely fine. So have a little bit of a go and let me know what you think. Just to help out a little bit, so for question 1, the answer that you're looking for here should be 0.58. I know it can help sometimes if people have done 1 or 2, but you're still not too sure. If you've got 0.58 for that, then your understanding is good, and you know that you're kind of going the right way with this. Awesome. Okay, so some good answers there. So for those ones, so Catherine, yeah, with that one, first 3, no problems. Have a look at 4 and 5 again. I mean, if you've got one of the scientific calculators, if you type in that decimal and press SD, it will switch it. Oh no, that's not going to work because it will go to a fraction, won't it? Essentially, they're just 10 times too big, those two. They need to be even smaller. And on the right as well, so maybe have a look at question 6 again, but question 7, question 8 are fine. Question 9 spot on as well. And yeah, question 10 is, yeah, question 10 is a little bit too small as well. But again, like we said before, you're not just going to be given a whole page of these, so it's actually probably harder working them out this way. Katie, yeah, so that's spot on for number 2 and number 3. Have a look at number 4 again, though, and have a look at number 5 again. They do tend to get people, so don't worry. Catherine, yeah, absolutely awesome. Great correction there. It's very easily done as well. You know, a lot of people are going to fall into this pattern of just like, oh, well, if it's a going from a percentage to a decimal, I'll just put 0 point in front of it, which does work 90% of the time. But when you end up with fractions that are smaller than our 10%, then we have to remember that we are getting even smaller. Same with the decimals going the other way. A lot of people will just go, oh, well, it's 0 point, whatever it is, you just remove the 0 point. Again, it does work a lot of the time, but not all of the time. So peace, absolutely brilliant. You got no problems there at all. Katie, that one it's a bit of a weird one, isn't it? So with that, just remember what you're actually doing with it. So with all of these things, when you're going from the percentage to the decimal, you're always getting 100 times smaller. So even for question 5, you've got to make that 100 times smaller there. Nicola, yes, amazing. Not been caught out there at all. That's great stuff. I'm going to go through these ones on the left then. I know that some people are still going to be looking at the ones on the right, but just to give you a couple of answers here. First three here didn't really pose any problems at all. Question 4, it is just remembering this will be 0.08. One thing that does happen, again, it's very, very common that they'll ask this type of question on an exam. They kind of are just trying to trick you a little bit, but they're just trying to see that you've got that deeper understanding. What you can always do is just check your answer, just a quick logical thought about it. Well, if I've got 0.8, I know that that is higher than 0.5. It's more than 0.5. And I know that 0.5 is 50%. You know, we've had this ingrained in us from school, so we know this. 0.5 is 50%. Therefore, 0.8 is bigger than that. Well, 8% is definitely smaller than 50%. So this cannot be true. So a little bit of a thought experiment there can really help. With our last one, I've never seen a question like this pop up. Doesn't mean it couldn't. Again, it is just testing. You know, well, if I've got 0.5% and I'm switching that to a decimal, it's got to get 100 times smaller. I'm just going to divide it by 100. Again, if you're happy with the idea of, you know, you can probably use a calculator for it, but if not, just remember what's going to happen there. Obviously, the 5 is going to slide so it gets smaller. So obviously, another one of our zeros is going to move across, and then another 0 as well. Okay, so let's have a look at the flip side of this then. So if we have a look at these ones here, so question 6, question 7, question 8, most people absolutely fine with these. It's just remembering it's getting 100 times bigger. Number 6 does throw people sometimes. It's quite tempting just to put it as 6%, but just think about what you're doing each time. It is definitely going up by 100. It's got to move 2 spaces. So you should have 60%, 54, and 92%. Now, 1.2, it does give you a bit of a strange answer, but it is correct. Essentially, it is more than 1. So this is a decimal that is bigger than 1. So therefore, as a percentage, it's greater than 100. If you were to write that as a fraction or as a mixed number, we know now that 0.2 is 1/5. So this would be 1 and 1/5, or 6/5. Finally, then 0.05 will end up at 5% there. Okie dokie. So that is all there is to switch between a fraction or to switch between a decimal and a percentage. It's just remembering percent out of 100. If you know that, then you'll be able to work all of these out, no problem. Now, there is one last conversion to do, and that is the conversion from decimals to fractions. Okay, we've looked at fractions to decimals, and we've done that by completing the sum using long division. Technically looking at it, we could go backwards and we could think like, okay, well, if I've completed the sum going this way, I could make a sum going the other way. And it does work, and it is a way of looking at this. I think it's a more confusing explanation though, so I'm going to give my own explanation, which I hope will make sense to you. We've looked at then the decimals and percentages and how to switch between them. So my method here, so we could easily go from a fraction to a decimal. We can go from a decimal to a percentage and a percentage to a decimal. The only bit that's missing is, well, how do we get to a fraction? What if I was given a percentage and I wanted to get to a fraction? What if I was given a decimal and I wanted to get to a fraction? The great thing is, we're going to do essentially from a percentage to a fraction is very, very easy. From a decimal to a fraction, we're not going to go this way. We're actually going to go back a step first before we go over to the fraction. So I will explain this using this example here. So if I've got a decimal, let's say 0.6, and I want to write this as a fraction in its simplest form. What I'm going to do, first of all, I'm going to go to the percentage. We can do this very, very easily. We know how to do this. It's just a case of making it 100 times bigger. You might think, well, why is he doing that? That's kind of counterintuitive. Hopefully, it will make sense in just a second. So I've now got 60%. Now, the whole trick here is just remembering what percent actually means. Percent literally translates to out of 100. So we can literally just write that as a fraction. That's all you have to do. To switch from a percentage to a fraction, you just write over 100. It's actually that straightforward and that simple. The wording of it itself, percentage, literally just means out of 100. When you see this sign here, the actual percentage sign, it just means out of 100. It is just, it's the exact same as writing over 100. So this is why, for me, it's easier to go from a decimal to a percentage. We can now do this with any percentage that we want. If you imagine, let's say I've got, I don't know, 37%, you know, what would that be as a fraction? It's going to be 37 over 100. If it was, I don't know, 28%, 28 out of 100. It's literally just how you say it. It's 28 out of 100. That's what it is. 12%, 12 out of 100. Do you see the pattern here? If at any percentage, if we want to get it to a fraction, we just write it over 100. We can do that. That's absolutely fine. The only thing that we need to do here is simplify a little bit. I've got this fraction, and that will get me 1 mark, guaranteed. If this was going from a decimal to a fraction, that would probably get me 2 marks. But if they've said, give your answer as a fraction in its simplest form, well, then all I have to do is simplify that fraction. And for most people, you will look at this and you'll think, well, it both ends in 0, so I can divide it by 10. And then I can half it, and I end up with 3 over 5. I can then go full cycle and check this if I want. If I complete this sum, 3 divided by 5, I will get 0.6 as my answer. If I do 6 divided by 10, I will also get 0.6. If I do 60 divided by 100, I will get 0.6. So the great thing here is actually, if I have this decimal, if I know that I'm just going to switch that to a percentage and I'm going to divide it by 100, multiply it by 100. Actually, when I mean, and again, with having the calculator itself is a great advantage here. If we haven't got a calculator, this is the method I suggest. Going from the decimal all the way to the percentage, writing it as the percentage is just out of 100, and then simplifying. It's the quickest and easiest way. If you've got a calculator, you don't have to do any of this. If you've been given a decimal and you've got a calculator, just type it in. If you've got one of these scientific calculators, if you just press 0.6, just type it in like that. When I press equals, it will just write it as a fraction in its simplest form for me, which is why these calculators are so useful. Okay, how is that for everyone? Is that okay? Are there any questions at this point regarding this? If we can go through, obviously we're going to practice this skill a little bit. I'm just hoping that the main understanding here makes sense. So again, if I had, let's say 0.8, to get this to a fraction, well, first of all, I know that's going to be 80%. And again, at this point, I'm not even doing any maths really. I know that's 80% straight away. So that is the exact same as 80 out of 100. So 80 out of 100, I can then just simplify that fraction all the way down to make it as simple as possible. That's possibly the hardest thing that we have to do with this. Hopefully that makes sense there. Okay, let's have a bit of a practice then. Sorry, I was going to actually remove these slides, but this is like a little bit of an extra thing just to show how all of these are linked a little bit more. 47 out of 100, if it was written as a fraction, if I complete that sum, is 0.47. Like we've said as well, because it is 47 out of 100, this is also could be written as 47%. This is just to kind of consolidate and show that all of these are the same. They are all linked. These two are the exact same. It's just the percentage sign written here is saying over or out of 100. When I complete this sum, I get to here. Okay, let's have a look at some practice questions then. So what I would like you to do is convert the following into fractions and give your answer in its simplest form. Now, the first two are going from a percentage to a fraction. So straight away, your first step, and it is a bit difficult because it's just having a bit of confidence. Just write it as a fraction. You know now that 30% is 30 out of 100. Whenever you're writing a percentage as a fraction, you just write over 100. What I then want you to do, simplify that fraction, see how far you can go. Do the same with question 2. Question 3 and question 4, what you need to do is switch these to a percentage first before you then write them in their fractional form. Have a go, let me know how you get on, and we'll review it in just a second. Okay. So peace. Yeah, that's spot on for number 1. Number 2, I've got the same there. And number 4. I'll have to just double check number 3 quickly because I've got a slightly different answer, but it might just be me. Oh yeah, of course, of course. Everyone can make mistakes. Yeah, you're absolutely fine. All of those are absolutely perfect. Catherine, yeah, okay. That is one of the fractions that you could have there. You should be able to simplify that one a bit further as well. Look for a common denominator or a common number that goes into both of them. And yeah, no, that's good as well for number 2. Yeah, they've started to get there. You can just simplify them a little bit further. That's all. But the idea is there. That's the most important thing. So, Katie, yeah, yours is spot on there. That is one of the fractions that you could get. You can actually simplify that one further, though. 5 will be, you'll be able to divide both by 5 to get it even simpler. But again, if you were given this question and it was, convert this percentage to a fraction, give your answer in its simplest form, on a level 2 paper, it'd probably be worth 2 marks, maybe 3. So if it was 2 marks, you're going to be grabbing one of the marks there. If you fully simplify it, then you get the extra. Catherine, absolutely brilliant. Yeah, so you're getting really good at obviously spotting how to switch between these. So, and again, that would be for switching from the decimal to the percentage and then writing it as a fraction. That's going to already get you 1, maybe 2 marks. Just think, can you simplify that fraction there? Nicola, I saw your answers earlier on. I wasn't too sure how you got them or if they were linked to a previous question or not. I'm not too sure how you've got them. I mean, if you wanted to pop over like a bit of a working out behind them or something like that, or if I think I might just go through the first one and kind of give that as an answer now, and hopefully that will kind of help a little bit. So for question 1, then what we should have here, so we've written our percentage out as a fraction, so it's 30 over 100. Again, if you've got one of these calculators, if you just type in 30 divided by 100, it will give you the simplest form. They are amazing. They're very useful. What some people might have done, and again, there's different ways to get to the simplest form. Some people I've seen have halved this, and they've got 15 over 50. What you can then do is divide that by 5, and you end up with 3 over 10. So it's just two different ways of viewing this. What you can do, I tend to here, because I know they both got a end in a 0, I can divide by 10 straight away, which jumps me straight to here. However, you can divide by 2 and then divide by 5. In total, you're still dividing by 10. So for our next fraction then, so we've got 40%. 40%, it just means percent out of 100. It's telling us what to do. 40 out of 100. I'm just going to write it like it's asked me to. 40 over 100 then, and again, it's up to you how you're going to simplify this. Some people might have halved it. You might have then, potentially halved it again. And ended up with, 10 over 25 or something like that. Eventually, when you go through and simplify it as far as you can, you'll end up with 2 over 5. And again, you can divide it by 10 at the beginning to 4 over 10 and then half it, 2 over 5. If you've halved it here, then you divide it by 10, you get the same answer. If you half it and then you half it again, you end up with your 10 over 25. Then you need to divide by 5. But you will inevitably end up at 2 over 5. So question 3 then, 0.12. A little bit harder. We need to convert this into a percentage first and then into a fraction. So this as a percentage is going to be 100 times bigger. So it's 12%. 12% is 12 over 100. When I simplify this, I get 6 over 50. I can then simplify further because they're both even still. And I end up with 3 over 25 there. Finally, then, if I've got my 0.08, if I multiply that by 100, well, I've got 8 over 100. I can half that, 4 over 50, and finally 2 over 25. So hopefully that makes sense. And that is really probably the toughest skill that we're going to have to do. But I'm hoping that you're okay. It's all based on the same things. If we're doing a fraction to a decimal, it is just simply completing the sum. Decimals and percentages, it's just multiplying or dividing by 100, which we can do. And when we're going the other way and we're trying to get back to a fraction, going from a percentage is the way forward, because percent just means out of 100. It's giving us a fraction straight away to work with. Okay, so we've got one more question here then, and that will tie us over for conversion. So what we have here is our good friend Leotard, which obviously is his real name. And he's just finished all of his exams and he's got his results in the post. His mum wants to know what lesson he's done best in. Leo's results can be seen in the table below. So here he knows he scored 83% on his English exam, 42 out of 50 in maths, and 24 out of 30 in science. Which subject did Leo score the highest in? Now, for this question, please do use a calculator. It's absolutely fine. This is one of the other questions, or the other style of questions which I was talking about. It's all about just comparison. Sometimes they're very straightforward. They'll just give you 4 numbers and say which is largest or put them in order. In this case, there's a bit of context. Because we have to read the information from a table, they actually have to give us an extra mark then, which is very nice. But what you need to do is look at these values and just think, okay, well, I don't know off the top of my head if that percent is higher than that, or if that fraction is higher than that. I don't know. If you look at all of them, just think, convert them all to something that is the same. Either switch them all to percentages, switch them all to decimals, or switch them all to fractions. Then you can compare them, and then you can work it out. So have a bit of a go. Let me know what you think, and I'm looking forward to seeing some of your answers. Yeah. Yeah, Nicola, that's absolutely brilliant. If you've got to maths, then obviously I've given the answer away there, haven't I? But why is it maths? That's the real question. But yeah, Nicola, yeah, you're working out there absolutely fine. That's brilliant stuff. Catherine, I think it said that the hand had gone up. I couldn't see the hand, but I heard rumours of it. Is everything all right?
Yeah, it's just that 42 out of 50.
Yeah.
Am I treating the 50 as 100%? Because I assume 50 would be, or is that a fraction? Or is that, I don't get it.
No, you're absolutely fine. That's a really, really good point. So it should actually, you're quite right. It should be written as, I mean, it's 42 out of 50. How it should be written, and it is just me being a little bit lazy in regards to not putting it in the proper format. It should be written like this as a fraction.
Okay.
Does that help?
Yeah, kind of. Yeah.
This one should be 24 over 30.
Okay, because I thought it was marks like 24 marks out of 30.
Well, that is what he's got, essentially. It's just different ways. So it is 24 out of 30. Again, it is just two different ways of writing the same thing. It's 42 divided by 50. It's 42 out of 50. But again, you would always see it written as a fraction like this, not like this.
Okay.
Hopefully that helps a little bit. Have a little bit more of a think about it, and then we can go through in just a second. All right. Catherine, yeah, absolutely brilliant, spot on. So what we'll do at this point then, we will have a bit of a look through these, and I'll just give you a couple of ideas. So with these, I think most people tend to convert to percentages. It's just something that people do. You can obviously compare from decimals as well. Fractions would be a little bit harder in this particular case. But essentially what we've got here is we've got three different kind of numbers. They're all different statistics essentially, but we want to put them all in the same form so we can compare them. So again, for most people, I'm assuming that they've done is you've looked at maths and you've gone, well, 42 out of 50. If I complete that sum, it's 0.84. When I multiply it by 100, I've got 84%. If I do the same with science, I've got 24 over 100, or 24 out of 24 out of 30. So 24 divided by 30 is 0.8. When I multiply it by 100, that is 80%. Then all I have to do here is look and go, well, maths is the highest end. 84 is bigger than 83, and it's bigger than 80. That's one way. What you could have also done is compared these as decimals. So I could have done, well, 83% is 0.83. And then I could have just compared them here. So 0.83, 0.84, 0.8. This one is still the biggest. Most people tend to prefer, when we look at kind of scores, it tends to be in a percentage. We only really kind of see this kind of decimal form when we look at probability. You know, there's like a 0.3 chance of this happening. What is the chance of something else happening? Which is a bit annoying because you could just write as a percentage and everyone would understand it a lot easier. But that's the same there. Little shortcut that you might have spotted, 42 out of 50, an equivalent fraction, if I double that, would be 84 over 100. So just by doubling it, I've immediately switched it into a percentage without having to complete the sum and then multiply by 100. And again, comparing them as fractions would be quite difficult. You know, we can get this one out of 100, or, you know, an 83 we could get to be out of 100, but they'd have to have a common denominator as well. 30 would be quite a difficult one. We'd have to find something that's in common with 100, 130. So we'd be looking at turning these into fractions that are over 300 each. Not to say you couldn't do it. Some people might prefer to do it that way, but just as an idea, I think this way, switching to the percentage is probably the quickest and easiest route there. Okay, so these are just kind of two examples from past exam papers. So I just thought I'd very quickly talk through these before we kind of recap and end for the session. So our first one then, and this is straight from an exam paper. I believe this was a level 2 paper. So it just says write 1 3/4 as a percentage. It's for 1 mark. So it's just testing that knowledge that you know that, well, okay, well, 1 is going to be the whole thing. Yeah, Catherine, amazing, straight away. So it's just converting this into a decimal and then into a number. So we know that 3/4, if I complete that sum, it's 0.75. I've now got 1.75. If I want to switch that to a percentage, I just got to make it 100 times bigger. So quite a nice little 1 mark question there. Part B then, so this is one that was from a level 2 paper. So again, you can see there we've got the 2 marks involved. So write 1 2/3 as a decimal. Give your answer correct to 2 decimal places. So this is what I was saying about that recurring decimal. If I were to try and solve 2/3, it will be 0.666666666 going on forever. So in this case, it would be, because we've got the 1 there as well, it'd be 1.6666666 forever. We just need to obviously write that and then make sure that we're cutting it off at 2 places. Just be aware, they tend to ask these types of questions with, this is when they tend to use a third. The third is that recurring decimal. A lot of people will say that, oh, 1/3, it's 0.3. 2/3 is 0.6. Wouldn't really work, because that would mean that 3/3, which is 1, would be 0.9. So it doesn't actually add up. You've got to have that recurring decimal in there. Again, this was straight from a level 2 exam on the non-calculator. We actually had this exact same question earlier. So write 8% as a decimal. It's just remembering it will be 0.08 for that. Okay, so those are a couple of exam examples then. What we've looked at today so far is we've looked at our introduction to conversion. We've looked at how to convert between these different types of numbers. So when we switch between these numbers, Catherine, no worries yet. We'll take a bit of a break in a minute. I'll go back in just 1 second, all right. So we've got our kind of how to convert between all these different types of number. Again, think about the shoes. They are all the same thing. They all have the same job, but sometimes it's better to use one than it is another. As we saw in that example a minute ago, easier to compare as percentages than it would have been as fractions, etc. So fractions to decimals, complete the sum. Absolutely fine. A fraction is an incomplete sum. If we complete that, we get to our decimals. Decimals to percentages is just going to be 100 times bigger. Multiply by 100 and divide by 100 if we're going the other way. If we're trying to get to a fraction, easiest way to do it, go from a percentage, because percent is just simply out of 100. It does just take a little bit of time to get confident with how to switch between these as well. But you know, a little bit of practice makes permanent. I'm sure you'll be absolutely fine. We've then looked at our worded conversion problems as well, and we've obviously covered that. That's all good. So for this session on conversion, that is going to be everything. So at this point, I'm going to stop the recording. Anyone watching this in the future, hope you've enjoyed it, and hopefully that's helped, and have a go at the assessments now. So I'll just stop that.